This is an excellent condition Commodore SFD 1001. It is a very nice floppy drive that looks like a 1541, but actually is more related to the Commodore CBM 8050 and 8250. The 8050 we've had on this channel before. I have two of those at the back of the camera and repaired those. The difference compared to the 1541 is that this drive also uses a 100 track per inch disk mechanism, so that it can pack 1 megabyte on these diskettes instead of the usual 2 times 170 kilobytes. If it's double-sided, and I think the SFD 1001 is double-sided, the 8050 is single-sided, the 8250 is double-sided. Plus, it uses the IEEE 488 or GPIP connector, just as its big brothers and sisters. So, especially in this excellent condition, I think this is worth quite a bit of money. It is not mine. It is here for repair by someone on the forums who kindly asked me to take a look. It supposedly has the power light on, but the drive motor doesn't turn. So this sounds like the 12-volt rail might be bust. So we will have to open it up. We will do a little inspection and test all the voltage rails. Most probably the drive will be detected by our Zoom floppy, hopefully. But first, as I said, we'll open it up and check what's inside. On the back, a quick look. It comes with the GPIP or IEEE 488 port. It has the regular fuse holder that the 1541s come with, which is quite nice because it's externally accessible and it has the usual power switch and everything like that. It is a model SFD 1001, 220 volts AC. We could probably mod the transformer for 240 volts, which will make the linear regulators in here run a bit cooler. We could perhaps also, if the voltage regulators are at fault, use one of the nice switching power regulators by Mr. Floppy, this being the 5-volt variant, which run extremely cool and with minimal noise, switching noise, but that will be up to the owner. I won't put in a switching regulator if the owner doesn't want that. I can imagine that they want to keep it original, so we won't do any modifications without asking. Yeah, the important thing here is also you can use any GPIP cable, but if you want to attach it to a pad, or if you want to attach it to something like this, which is a GPIP interface or IEEE 488 interface for the Commodore 64. The Commodore computers always come only with an edge connector instead of this IEEE connector. So you need a cable or an adapter. The cables with the edge connector at the end are themselves unicorns by now and are extremely expensive. But you can solder some adapter because the connectors are still easily available, and of course edge connectors are as well. This here being a completely different thing. This is a CBM D9069, which is a flash hard disk emulator, basically, sort of. It is a mass storage solution, which we'll deal with in a different video. It's similar to the SD plus PAD, or what it's called. You can attach an SD card and have mass storage on your pad. But today we want to have mass storage on the pad or on the C64 using the SFD 1001. So let's open it up. And here is the whole beauty. It is a very interesting drive indeed. I've had a little look around. I printed out the schematics. It is similar and also very different from the 8050 and extremely different from the 1541. Let's go across the main components that I can identify. Over here, I would say this is the analog section for the read-write heads, because this is the connector for the read-write heads. There are two, because it's a double-sided thing. I think this one has the same mechanism in here as the 8250 LP or low profile, which I've never seen in person so far, except for in a museum, but I haven't had my hands on one. This has to be the motor signals for the spindle and the stepper. It seems the low profile drive has a drive where you have inductive coils on the PCB. So that's something that was used on later 3.5-inch drives as well to make them very low profile. But this is, I guess, this whole section, and there is probably something along the lines of a reset circuit as well. This seems to be an op-amp. Maybe there's something for resetting somewhere here. At least on the 1541, it is roughly in the forward section. But there's some other very interesting stuff. We do have two ROMs here, which are probably the DOS, I would guess. There are two 6532 Riot chips, and maybe this here could be a Riot as well with a custom ROM, maybe? It's a 901885, because if I remember correctly, there are two Riots which have no ROM, but are just RAM input-output for one of the 6502s, because this is one 6502, probably the one driving the GPIP. And there's another 6502, which is usually used for doing the NNT coding of the, I don't know, GCR, FM or MFM data. I'm not sure what encoding they're using on this drive, but it's doing all that. There's also a VIR 6522. Everything is from mid to late 1983, so this is probably when this was built. The VIR, I would guess, is probably doing stuff related to driving the motor. Could be. There's an EEPROM here. Not sure what that's for. Probably for this part of the 6502, I guess. But this special adapter board here could also mean that this is actually a regular Riot with a ROM and some logic. This is a 74LS14. Very confusing, definitely, because there are versions of the Riot, the R-Riot with ROM and ones without the ROM. I always forget which one is which. Maybe we can take a look at the schematics, what they say. Okay, there's a 6532. So that must be the regular kind, I guess, because that has to be a generic part, which is also used, for example, in the Atari 2600. So I'm not sure why they use this adapter board here. This one here, I guess, is the voltage board. Red colored would suggest that it's only 5 volts. This thing over here looks like a huge, massive heatsink. So I guess somewhere below must be the linear regulators, but they're not directly attached there. So there must be something hidden under this stuff. And of course, there are now multiple reasons why this drive doesn't work. We haven't turned it on yet. I'm not ready to do that. If the drive motor doesn't move, it could also be one of the supporting chips here in that area that's driving the motor. Could be something as simple as a broken 6522. Could be the 12-volt rail. There are black electrolytics, which at least on the C64 are known to leak, but these here, I think, look fine. I don't see anything. The board looks to be in immaculate condition. This is such a nice, lovely drive. yeah, I don't know. It's all the drives I got from this person. The last couple drives that you saw on this channel were also from the same person. They are always in such pristine condition. It's amazing. What else do we see? We see a product number. Is there also assembly number? No, the product number is 251203. I don't see an assembly number down here neither. There is a connector over here that goes somewhere below. Would be interesting to know what that is. It has a latch to keep it attached. There's another socket over here. This looks more like the usual spindle motor stuff or something like we see on the 1541. But again, not sure. I think I will have to download and print out the service manual because this is definitely different from what I'm used on the 8050 and definitely different from the 1541. It is similar, definitely. There are concepts, of course, that are in either of those models. Also, I do see two SRAM chips here, which are probably for the other CPU, because if I remember correctly, as I said, the riots are the RAM for one of the CPUs, and then the SRAM must be for the other. They are Toshiba branded, 2116. Yeah. So that's very interesting. There is another probably ROM chip, a 901467 by MOS. By the way, the EEPROM here is a D2716 made by NEC. So a 16 kilobit, 2 kilobyte, which is small, which is in line to what I would assume would be in here when we would have a Riot plus a ROM. But I think this might be an alright. I will look up these chips and get back to you. And then we might start plugging some cables and have a look at what's underneath this whole contraption. If we see the voltage regulators, and we can perhaps drive the voltage regulators without having too much attached and destroying too much. But I mean, it was turned on and it did seem to survive that. So yeah, but I want to be very extra careful with this drive because it's so rare and in such nice condition. All right, I looked up a little bit of the schematics and all the other stuff. Quite an interesting device, I must say. So very quickly, yes, this one is a Riot, and these two are ROMs. This is probably the GCR ROM, which has the code for decoding GCR and the group code recording that Commodore used in most of their drives, which was also used in Apple II drives. Not sure what's on this one, but we could dump it, but maybe there's a dump somewhere. But it might be a good idea to dump this as well. If I don't find anything, but I think there should be images of that because the SFD 1001 can be emulated. Other than that, it's as we expected. There's no voltage regulators on here, and we'll look at the power section of the drive just now. And here is where it gets really interesting. I think the yellow and gray thing that we saw before is actually the 12-volt line coming from over here. The 5-volt lines are coming from here, and the section is totally different from the 1541 and the 8050 at that. I think the 8050 and the 1541 look more similar. We do have two beefy bridge rectifiers with large heat sinks, or maybe it's this one here is the voltage regulators. So this must be the rectifiers, big filter caps for the 5 and 12 volt lines. The rectifiers have a heatsink, which on the 1541 is not the case. And they are beefy 6 amp types, I think, from what I've seen. Then there are two linear regulators for 5 volts and 12 volts each in a TO3 package, not a TO2 like in the 8050 and the 1541. There's two smaller caps here as well, augmenting the larger filtering caps, I guess. There's the regular paper-covered transformer, which is looking quite the usual type. It's set more to the outer edge of the board. The drive mechanism itself looks very high quality, even has a protective little metal sheet on top. I hope this is good because those are almost irreplaceable due to the nature that they are 100 tracks per inch, which is very uncommon. Usually you would have 96 tracks per inch and 48 tracks per inch, so 100 is very weird. Yeah, but seems to be in good condition. What I would do now is everything is unplugged. We have the heads unplugged, we have the stepper motor and everything unplugged. I would plug this thing in, turn it on, measure the two 5-volt rails and the 12-volt rail. This is a linear power supply, so it should be safe without any load attached to it. And we can see if the 12-volt and the 5-volt are good without load. And there we go, testing the 12-volt line first, because that is where we suspect an error. And it goes to 14.4 volts, not under load. Might be okay, but seems high, I would say. I would have assumed 12 volts coming from a regulator. Let's have a look at the 5-volt section, what it says. Interesting fact, the device is turned off and it kept at 12 volts for a long time. And you can see it jumping around a little bit. So there might be charge still in the capacitors. So always be careful, capacitors might be charged. But it took a really long while. And now we're on the 5-volt rail. There's still some residual energy there. And that is spot on, 5 volts. Which looks to be correct, I would say. The question now is, can we somehow test the 12-volt rail? What I would do is, I think I would plug in, also I turn it off, and you can see it's still on 5 volts, because, well, there is still voltage in there. What I can do is use my power resistor to discharge this whole thing. See if we can do that. Yeah, there we go. And it's discharged. What I'm going to do is I'm going to plug in the power resistor into this piece here. And then I'm going to clamp my probes onto the power resistor. That's how I usually do it. I have these nice little crocodile clips that can be plugged in the front of these probes. Very nice. And then we can have a look. Okay, here we are. I'm holding this in place because the pins are a little bit too small. And it's straight to minus 12 volts, so I swapped it around, but it's a solid 12 volts. So the linear regulator, when used like this, and it's getting slightly warm, it's a 50 watt power resistor, it's working fine. 50 watts, but we are at 22 ohms, so that is, I don't know, half an amp or something, roughly, putting out something probably around 5 watts or so. So you can feel it, but it's not dangerous. Dangerously high amperage or temperatures. So I would say the 12 volts look fine, especially on a load. It is a little bit high if it's not loaded, which is surprising because I would assume that the voltage regulator wouldn't run that hot, but maybe that's how they work. but under load it seems totally fine. I can have a look with the scope and this thing attached, and then we maybe also see if it's the same behavior. So the scope is set up. I'm clipped onto the power resistor down here. I will still hold the pins in place out of camera focus right now, but yeah, I'm turning it on and we get a nice and solid 12.2 volts. This is totally looking fine, I would say. I need to zoom out a bit to see maybe some noise, or zoom in for that matter. No, this looks completely flat as it should. There's a tiny bit of noise here. If we go to AC coupling, we can probably see that on a smaller scale. Yeah, there is a little bit of line noise that we're probably picking up from, I don't know, all the lighting around here. But DC coupling looks totally super nice. Has a 12.2 volt peak. Yeah, looking totally fine. Let's switch that off. So I would say the 5 volt and the 12 volt supply is totally fine. Actually, we can check the 5 volt rail here as well. Let's plug it in like so. I think that was the other way around. Yeah, something like that. And yeah, looking totally fine. Great. Okay, under load, everything's fine, no ripple, no anything. It's a perfectly fine, healthy linear power supply. I think that means it's safe to plug it in. I'm gonna put the main PCB back in, hook everything up, except for the read-write heads. If there's anything wrong, I don't want to destroy them, but we can try and exercise at least the drive and see if we can make it spin or anything. We can't use the regular 1541 diag, but we'll figure something out. Right, we have a terminal running for OpenCBM. I'm gonna turn on the drive again. Ah yes, there you could see the dual color LED. I'm gonna run CBM control detect. It is identified as an 8250 with DOS 2.7. The 8250 would have been the larger model with 2 drives, but this is basically the same. Electronics wise, it is uses the same mechanisms as the 8250 LP, low profile. So there's that. So okay, that does seem to work somewhat. Let's try to format something. Can we do that? Okay, there is a P command, a PETSCI command with new disk, blah blah XY. It did the head bump, and then that was it. Okay, there is something wrong. Okay, once more. Control status. Let's check the status. The device is not returning a status right now because I think it is trying to... It's not spinning. I heard the head bump more or less, so that seems to work. It seems that the motor is not turning, the spindle motor. You can see that here. Nothing is happening. I think the drive is confused. It doesn't return any status. If I reset it, basically it returns an OK status. So I think the issue is the drive motor, the spindle motor. My hope would be that it is not turning. The question is, I have to look up the pins. It might be either the yellow cable right at the far back or here in the front. Let me quickly show you. So things turned off right now, which is safer for me to poke around. So I'm wondering if this back here, this thing here is the motor drive cable, the spindle drive cable, could be, or if it's one of these. It's definite that the stepper motor is driven with this, but it could also be that the motor on signal is on the here as well. So I'm gonna check out the schematics, and then we will hopefully see that one of the logic gates here might be driving that. If not, it might be that something is physically wrong with the spindle motor, which would be bad. That would be the worst thing, because those drives are hard to come by, as I said. So my hope is that it's something simple. Okay, I have a little bit of bad news. I'm attached to P1 on pins 3 and 5, which is the plus 12 volts, which I would assume goes to the spindle motor, according to what I see in the schematics. And I'm also attached to pin 5, which is the motor on signal, which is active low. And if we look around here to my trusty oscilloscope, now the drive is off. And when we turn it on, we see both go high, the 12 volt to 12 volts and the motor on to high. And if I would try to format, I see the motor signal going down and then going back up again, because there's nothing else connected. So it sees a write protect signal, which is kind of bad news, because this would mean that the spindle should start turning. So there must be something wrong either in the motor itself or on the spindle motor control PCB, which is probably somewhere buried down beneath here, probably on the bottom of the drive. Hopefully it's nothing to do with the motor itself. Hopefully there is still some kind of gate or transistor that turns on the motor. Otherwise, we will be very much out of luck. Okay, I think maybe I did this the wrong way, but it's definitely also a way. I took off the rotor with some brass washers and some precision screws. That seems to have worked fine. Also, I can take out the board now, which is quite interesting from the other side, but I can't pick it out completely because there is something still attached there. And that's why I said, maybe I should have done this from the top, but I didn't know. So I'm gonna desolder this thing here. I already desoldered this one here, sorry, didn't show you that. There's another plug here with a flex cable, and that will be removed now, and we'll reattach it later. So the actual way is to go from the top side, but then you need to take off all this stuff here. And yeah, I didn't know before, so yeah, but I will show you how to get this back together when I reassemble this. Yeah, so what I want to do is I want to put some fresh solder on the flex cable here. Okay, this is actually quite interesting. This is the motor PCB. Usually you won't see that because the disk mechanism would be on top of that, the spindle mechanism. But since I desoldered this little flex cable that goes here, we can see that we can reattach this with a little bit of hot glue here if necessary, so that it doesn't flap around. There is not that much on here. There is a servo by, I don't know, servo controller with heatsink attached. And I think these here are the big offenders. There's also a couple of smaller capacitors here that have leaked. We'll take them off all, I think, yes. There is also some kind of sensors, I guess, maybe Hall effect sensors for phases. I don't know. Who knows? But this is definitely an interesting concept. Haven't seen that a lot. This is probably the index hole sensor, I would guess. Maybe. Yeah, I think so. Probably. Or at least it's the LED for the index sensor. These here look actually pretty fine. If we turn this around, there's a lot of corrosion here, 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 and here. So first order will be to remove all this and desolder all the leaking caps. I'm gonna leave these in for now. I think these three are non-polarized capacitors, very important. So they don't have a stripe. They can take voltages in either direction. Very important if you replace them, that you replace them with other bipolar caps. Yeah, but other than that, I do have a list from a vintage computer federation, whatever forum, German forum. Somebody made a list of the caps, and there's also the service manual, which should also tell you. Yeah, but I'm gonna add a little bit of fresh solder because it contains flux, which will already resolve a little bit of the corrosion and make desoldering much easier. And there's already a sizzling that I can hear. And the fishy smell, of course, that is to be expected from these capacitors. And this is actually quite interesting because not all capacitors leak, but there are some that are much more prone to leaking than others. And I am having really a hard time here. Getting the solder to take on due to the corrosion. Actually, what I might do is I might add some pure flux on there, which will eventually be coming down from my cupboard here. So I'm gonna put some flux here. This is synthetic rosin. So I distributed the flux on here, and I'm gonna wipe off the tip and then just flow the flux around here. And yeah, it's already getting shinier. It's already better. And we will have to remove the corrosion also under the solder mask, solder stop mask here, because that will eat through the traces if left unchecked. So the order here is put flux on, put a little bit of fresh solder on, then desolder all the bad caps, then clean off the PCB, remove solder mask when necessary. You can use either this fiberglass pen, or you can use like a Dremel with a slightly abrasive tool attached, which I often use. They're little like ball-shaped attachments or something like that. I'm gonna turn on the desoldering gun again, and once that's back up to heat, we will remove those and then clean up the board. So we took off a whole bunch of capacitors. Some of them didn't seem to leak yet, but I have a full set to replace them with, I hope. Yeah, but these here, the little stubby ones, they totally leaked. There's green stuff on them. These little ones here as well. I think there were 2 or 3 who didn't seem to have leaked, like this one here, but I don't trust them at all. This one here also leaked, obviously. The electrolyte usually smells quite fishy. This here was okay-ish, but there's a lot of dirt on here now, and I will start scrubbing away now with the IPA and a brush like this, anti-static brush, and then we'll see where we are, and we'll remove the remaining crust. I already found one broken trace down here. This is really eaten away pretty badly. I think I need to reinforce the other hole here with some wire as well. It does still make contact, but all this dark area here should actually be bare copper, but there is not much left. Up here it also looks nasty, but not quite as terrible. I'm gonna use my Dremel now because the fiberglass pen is really annoying and makes a lot of little shards basically. Yeah, so let's try and remove a little bit more of this, and especially of this up here. And let's see what else we have to fix. Let's zoom in to the worst part. Here was a capacitor, here was a capacitor, and here was a capacitor. These 3 were the worst ones. This capacitor's leg was connected to this resistor's leg. The resistor's still there. And I do have some continuity over here, but this whole thing should have gone to a pad that was eaten completely. So we definitely have to get a wire through here and then connect all of this again together. This here still has connectivity over here, here, and then over here, I think. No, over here. Okay, that's fine. We do have here a pretty destroyed thing that goes over there, and but that is still fine. This here makes its way over there. That's still fine, although part of the pad is already missing. This here goes over here. That's fine. That's all good. But this part here should be connected to this part. So we do have connectivity up to here and here, but not here. There's a tiny break here, and I would suggest running a wire from here to here probably. So this will be really ugly. Let's see here. We do have a little bit of destruction here, but that's fine. This part is also fine. This part, no connectivity. Everything here is eaten away roughly here. So yeah. Also this part here seems to be rather destroyed. So we need to get connectivity all the way over there on the far side. And I think this is connected, but the pad isn't connected anymore. So there's some real destruction here. So we can attach a wire from here to here and here to here. And this way around, doesn't matter. So this is also pretty much eaten away. The third center of destruction was here, but this is actually pretty okay. This part as well. So this was minor, basically. Yeah, leaves the last one that we already looked at. I think we had established that this here is gone, whereas this is still there, but not great. So we need to connect everything here together. Yeah, it's not great. It is rather terrible, but I think it is salvageable. The capacitors have been replaced, and as you can see, I also took out the whole mechanism because I ripped the flat flex cable here and I repaired it using a Bosch wire. Yeah, I will link to a disassembly guide in a German vintage computer forum, which I should have taken a look at first, but I didn't know about that. So you basically have to take out this whole thing by mostly disassembling the whole drive. That is actually the correct way. The capacitors are in. These I didn't have in a short enough package because all the capacitors have to be really short to fit under the drive assembly. And this one here neither. So I used an SMD component here, which is not the absolute correct replacement, of course, but I hope it will work anyway because these are MLCC caps. Yeah, and that's obviously different from the electrolytic caps. The other two are here on this side. They are so tiny you can barely see them here and here. But they're actually pretty easy to install on this board. And same with this, especially since the pads here were more or less gone. I should probably check for continuity over to this side, but I think there was still continuity. I think I measured that. Anyway, this should be it. I will put solder mask on there once I figured out that everything is nice. I had to put in a few magnet wires here and there to restore the broken traces. Same up here. Doesn't look pretty, but I tested for continuity on all of those and it seems fine. So now we can put this all back together and cross our fingers that this thing will come back to life. First order of business is mounting this thing back under the mechanism using these 3 screws. That's also how you actually get there. Be careful, these are brass screws and they're not very hard, they're rather soft. Also be careful of the head assembly because this here is still attached. It will go back in here like so in a second. Now everything is mounted down here. You can't see that right now. I'm gonna switch a bit around. Right, so you can see this. This is now mounted underneath and should be fine as it is. We can still reach the stuff that needs to be covered in solder mask, etc. And then we can carefully slide this under and mount this back into place. If we can actually think Goes something like this. Probably like so. And there's a ton of screws for that. Now that we have this in place, this metal shield is being installed. It has to slide under this part and goes over this mounting hole here and over this here. And there is one little brass screw that goes in from the top, and this whole thing protects the head assembly, which is quite nice because you don't have that on the other drives. And then there is a grounding lug that is unused from what I can see, I think. But still, we put it back in this stack of washers and hope for the best, I would say. So this is nice. This is all solid now. Next thing, there are two recessed screws here that are loosened a little bit. This allows us to add the faceplate back into place. Without the faceplate removed, you can't do anything either. I do hope that we can use all this. Then there's the lever, and it's in the locked position. Without it being in the locked position, you can't properly disassemble it. And there's a really tiny screw that you don't want to lose, and that holds the lever in place. So there we go. I think this should be it. I'm wondering if it is possible to insert a diskette. We don't care. Oh yeah, that feels good, yeah. Okay, I think this might work. So I'm gonna go on a limb here and throw away all these nasty capacitors. And I'm gonna put the drive back into its housing together with the, what do you call it? The main board, actually. The drive gets mounted with these screws with little washer rings, like these spiky ones. There should be 4 of them. Unmounting and reassembling this particular drive is quite a workout, I must say. There are a lot of screws and a lot of stuff that can go wrong. Obviously, I will have to unmount this thing once more if it actually is working, because there is still exposed copper, and we will add stuff to that. So I'm only screwing in the drive mechanism here fully, and then securing the main board with like 3 screws or something so that it can't wobble and can't move. Now we can mount the main board, carefully routing all the cables. So I'm gonna fasten everything near the plugs. This is keyed, so there is a pin missing, so you can't plug it in the wrong way, which is nice. This also goes in only one way. If you look closely, this is also keyed. So this goes in like so. And this is for the LED, which would be nice to have. Let me see if I can grab that. All right, I improvised a little bit. I think this should work too, because the LED is basically just 2 LEDs in one package, with the cathode in the middle, I think. So let's see if this works. I am plugged in. I did not power it on yet, but I'm gonna power it on now. And this is actually looking rather nice. Probably I plugged him in the wrong way, that we have red and green inverted, and it's quite bright, but not as bright in person. So this seems to work. which means we can hook it up to the Zoom floppy with the IEEE cable, which I'm gonna do now. Turning it on again, looking relatively good. We can detect it. Let's try and send a format command, just like this. And nothing happens. So we indeed did not repair the motor, I think. Yeah, there's nothing coming from the motor. So nothing blew up, but the thing is not working yet, which is a shame, because now I have to take it apart again. Interesting. But did we plug everything back in, I wonder? No, we did not. We forgot to solder in the power connector. Okay, let's do that. Okay, the motor power connection is soldered back. I had to disassemble everything. I now hold this in place only with one screw and with two screws over here. Let's power it on and hope for the best. It is powering on. That is good. Let's take the floppy disk and see if it spins. No, but that doesn't mean anything, I think. Let's turn this off again. Ah, there was spinning. I heard spinning, which I hope is good. Let's take the Zoom floppy again. Plug that in. And again, hope for the best. Zoom floppy is on. Device is booting. Detection works. Now let's try the formatting. Okay. This obviously failed because no disk inserted. Let's try again. Okay. Motor spinning. Probably formatting in progress. It is lighting only the red LED, which might be the green actually, because as I said, I probably plugged it in the wrong way. I hear head stepping. Okay, that's a good sign. That's an extremely good sign. It took a while until I heard the head stepping. So I'm not sure if there was a kind of retry or something, but usually you would see the error LED flash. But this is looking really good. This does use 74 tracks or something like that. So it does take 2 minutes or something to format a whole disk because the Commodore drives are notoriously slow. But this is definitely back to life. I like that. Yeah, let us fast forward through this and I'll tell you the outcome. The floppy drive stopped. Let's check in the terminal if that is actually a good thing. Like so. It says okay. Well, then we can do a dir on that. And we see the test disk with 4,133 blocks free. So let's try to put some stuff on there. For example, we can hook this whole thing up to my pad. So we can upload my version of Adalbert Kirk's Zork interpreter or Infocom interpreter. So we do a CPM copy and something like that. We will use the Z3 version because that is actually working fine. And that does look okay, I would say. I will try to fill up the whole disk to see if it works fine, but this is definitely good stuff, so to speak. Yeah, let's upload all the Zork games onto this. The nice thing here is you have 1 whole megabyte and can put a lot of games on there. Of course, many games will require a 1541 due to their fast loaders, etc. But some games and stuff, like for example this Infocom interpreter on the C64 at least, will run just like this on the SFD 1001, I guess. Yeah, it's actually also not terribly slow. Zorg 1 is 83 kilobytes, as you can see, and it's copying with, thanks to the parallel interface that is the IEEE bus. So I would say this drive is fixed, maybe? I do have to put on the solder mask to keep more corrosion from happening. But I think the replacement of the capacitors worked fine. And it seems, I'm not even sure if the index LED was actually needed. I think it's not being used. But who knows? Yeah, I will definitely try to fill up this disk a little bit more to see if both drive heads are working. Should be, because the formatting worked. So yeah, I'm gonna copy a little bit here and I'll report back once this is done. The drive worked flawlessly. I'm not sure about the performance, but it did not throw any errors. I copied 8 different Infocom games on there. There was even room for 1 more, I think. Or you can just play those games and have 600 blocks free worth for save games, for example. And for comparison, 600 blocks is, or 640 it was, I think, is basically the free space on a 1541. So we have 8 games plus 1 save disk. That is actually amazing. So the SFD 1001 is a lovely drive. Sadly, it didn't get used that much. I'm gonna zoom in a little bit so you can roughly see what I'm doing. I'm using this UV lacquer, I would say, to prevent further corrosion. I will try and apply it in not so great amounts, and I'm gonna put some paper here. If I drip or something like that, just gonna paint it very thinly over all the exposed copper. You can remove it, you can scrape it away if you need to replace anything here in the future. I try to leave the solder alone, more or less. Not sure this is going to work for all the parts here, but I'm trying my best, so to speak. And people also use nail polish, I heard, which is also fine and actually can be removed more easily with by the use of acetone or nail polish remover, obviously. So that does have an advantage. I'm not sure if there are any disadvantages. Fact is, this here has to use a UV light for curing. So if you don't have that, you need to buy that as well. I'm using this USB powered UV light. There are battery powered ones as well. I'm just gonna turn it on and put this on here and let it run for, I don't know, 3 minutes or something, and then check back and move to the next spot. There you go. The exposed copper is all covered in lacquer, I would say. Seems to be fine. I would say this is a good drive now, and we can reassemble everything one last time. Afterwards, we will hook it up to the pad and see if we can load up the games that we copied to the disk. If that all works out, I would say this drive can go back to its owner. And I must say, I do like this drive. It is nice and compact compared to the 8050 or the 8250. I think it should be compatible with the 8050. We can try that out as well and see if we can read a couple of the discs that I have for the 8050. But should you get one for yourself? Probably not if you're not using a pad or plan on running a BBS on an original C64 with lots of disk space. So they are a little bit temperamental. They are difficult to work with and restore. But they do have their charm, especially coming in the same package as the 1541. That's actually pretty nifty. So I'm gonna put everything back together and then we'll see what this thing can do. Here we are at my pad 3016, which is actually upgraded to a 3032. So it has 32 kilobytes of free memory. And yeah, the SFD 1001 is attached. This is listening to drive ID 8 and my 8050 is also on drive 8. So this is unplugged, it's not on, otherwise they would collide. And as you can see, we can read the disk contents here and we can even load the interpreter. However, it does not run, and I can explain in a second. This is now loading the interpreter, and when we try to run Zorg, it will actually work this time. Oh, that's interesting. Okay. But when I try to load one of the later games on the disk, it will not work. And I think that is due to the fact that the drive code here that accesses the drive is probably not yet augmented for the SFD 1001. I'm not 100% sure here. The game is loading up. It has to do a whole lot of parsing on that particular data file because there's no random access on regular files in CBM disk drives because they're actually rather stupid. But there you go. This is Zorg 1, west of a house. And that's actually quite neat. If we were to try a different game, let's say, first of all, let's call up the directory again. We, for example, have Tristram Island. We can try that, or Hitchhiker's Guide to the Galaxy. So let's load up the interpreter once more. Run it, and then we enter a different file name like Hitchhiker's Guide to the Galaxy. And that is actually also working. Lurking Horror didn't work. Not sure what was up with that. That didn't work. But okay, then that might be actually just fine. So obviously it is rather compatible to the 8050. 8050 support got added a couple years back after I asked the author of the interpreter, BitShifter, and I also hacked the interpreter. You can find that on my Codeberg repository. I added the file name input, for example, so you can put multiple games on one disk. And yeah, that's actually pretty nice. This is, of course, Douglas Adams' Hitchhiker's Guide to the Galaxy. Here we go. Working very well. It is pitch black. Let's open our eyes. There's the disk access again. Oh my, there, okay. Get up. Very difficult, but you manage it. The room is still spinning, it dips and sways a little. Okay, that's pretty cool. Let's quit this game as well. Okay, there we go. machine is rebooting. Now let's put in a 8050 disk, which is also loaded up with games. So if we do that, first time around, it doesn't like that. But second time around, it actually notices, okay, this is a 8050 disk, single-sided. I think at first it got a little bit confused, and there's the same stuff on here, just a couple of different games with a bit more of a hacked interpreter here, but yeah, we can run a game like Planetfall maybe. Let's try that. Let's see if that works or not. Yeah, seems to work. So, if you have a pad, the SFD 1001 is definitely a super cool drive to own. I mean, I do love the style of the chunky 8050, which fits very nicely with the 3016 and the 4016 and 8032 and so on line of machines. It is a style of their own, but this here is definitely taking up much less desk space for a lot of disk space, because this here has 1 megabyte on one floppy disk, whereas this here has 1 megabyte on 2 floppy disks, which is basically the same drive, only single-sided. But there you go. If you have an SFD 1001, you know what to do. The capacitors have to be swapped out. Better to do it yesterday than wait any longer. So yeah, but for today I think that's all I can show off. The drive is back in working order. It will go back to its owner and hopefully have a long, good and productive life and give a lot of joy to the owner and their floppy disks and machines. Definitely a very, very cool machine. If you want to know more about the stuff that I'm doing, all the links are in the video description. Make sure to follow me on Mastodon. It's chaos.social/@root42. There's also Patreon links, etc., etc. But since this is a hobby, I post only once or twice a month, whenever I got time. But for today, thank you very much for watching, and yeah, let's enjoy a little bit of Planetfall.